So we're going to turn our attention now to a new type of synchronizer in Java that we haven't covered before in detail called the condition object. And today I'll talk what a condition variable is, which will be a motivation for condition objects, and then we'll talk about condition objects. These concepts are rather tricky, so I recommend you go back and watch this lesson again on the video and read the links carefully because it's a little subtle. You'll need to understand how condition objects work in order to do assignment 2B, which has been released, and I'll be putting out the video for that shortly. I'll also give you an example of a human known use of condition variables that might help see the bigger picture of how they work. So a condition variable is a synchronizer that allows a thread to suspend its execution until some condition is satisfied. And it may need to do this repeatedly because it may take a while for the condition to be satisfied. So it may take several iterations for things to actually get to where you want them to be to make forward progress. The thread whose execution is suspended on a condition variable is said to be blocked on the condition variable. And we'll see later that this works by parking the thread on a queue as part of something called the wait set. And it'll stay there until it gets released. Condition variables are often used when mutual exclusion alone is inadequate. So mutual exclusion, of course, is something that's provided by Java's reentrant lock, as well as some other things like a spin lock or the synchronizer, the synchronized keyword that's part of the built-in monitor object. Here are some examples of when mutual exclusion may be inadequate. So mutual exclusion, if you're not careful, can inefficiently use resources. For example, if you busy wait and just sit there and spin, as we've talked about before, then you can end up with unnecessary overhead waiting for something to be available. There are situations where that makes sense, where you need to have quick responsiveness, but in general, you need to be careful not to overdo it. Mutual exclusion mechanisms are also inadequate to ensure coordination. And this basically occurs when a thread encounters some shared state condition that prevents it from making forward progress. So, for example, if you're trying to remove an element from an empty queue, you need to wait until that queue is not empty. So that would be an example of something that requires coordination, and mutual exclusion really isn't the right choice for something like that. Okay, so we'll see there's other examples of conditions where you need to wait, and mutual exclusion doesn't really give you the right vehicle for doing those kinds of things. To alleviate these inadequacies of mutual exclusion, condition variables are implemented as a queue of threads that are waiting for some condition to come their way or some change in a condition to occur where the state of the program may now reach a desirable point where they can make forward progress. This queue of threads that's blocked, waiting to get access to some resource, is called the wait set. And you'll see more about wait sets as we talk through the semantics of the methods that are defined on the condition object. But from a condition variable point of view, the queue of threads is known as the wait set. Rather than sitting there and spinning in some kind of busy wait, threads can use condition variables to wait for certain conditions to be satisfied. Let's talk about a real quick example of a human known use of condition variables. So let's imagine, for sake of argument, that you decide to make some extra money by going to work at a pizza delivery place. So in addition to being a student, you're also going to deliver pizzas in your spare time because the demand for pizzas is always strong. When times are good, people order pizza. When times are bad, people order pizza. So pizza is a recession-proof economy. So the way this might work is you might go and hang out at the pizza parlor where they cook the pizzas, maybe you and some friends. And the protocol for delivering a pizza is you have to have a pizza and you have to have the keys to the delivery vehicle. And when you have both of those things, then you can go off and deliver the pizza. But when you don't have both of those things, you're just going to sleep because this is like a second job or this is another job, and so you're tired and want to rest. So you have to have both things. You have to have both the keys and the pizza. And so the protocol works as follows. When the cook finishes cooking the pizza or the next pizza, they put it on the counter and ring a bell. They signal it somehow. And likewise, when someone returns from delivering the pizza, they put the keys back on a hook and they ring a bell. Whenever the bell rings, all the people waiting to deliver the pizzas wake up, and then they try to acquire the pizza and the keys. And they all do it in that order. And if they get the pizza and the keys, then they can go deliver. If they only get one of the resources, then they have to go back to sleep after releasing the resource, of course. So the model there is that you have to wait for certain state to reach an appropriate condition or a condition to occur with the appropriate state. And at that point, you can make forward progress. And this is what's often called the guarded suspension pattern, as we'll see in just a moment. So you only get to do something when you get all the resources that you want. And those checks can be arbitrarily complicated.